This is a circular motion problem. We have a power saw that has a 7¼ inch diameter blade that rotates at 5,000 revolutions per minute. So the first thing I notice is that it's a 7¼ inch diameter. Well, whenever we're talking about circular motion, we're always going to be looking at radius, not diameter. So I'm going to go ahead and make myself a note that my radius is going to be 7¼ so 7.25 divided by 2, just to make sure that I don't make that mistake somewhere else in the problem. Then it says find the angular speed of the saw blade in radians per minute. So the angular speed, remember, is your omega, and that's equal to theta over t. And right now we have our angular speed in revolutions per minute. So I have this is equal to 5,000 revolutions per minute. And it says that it wants me to find the angular speed in radians per minute. Well, for each revolution, how many radians do I go through? I go through 2 pi radians per revolution. Notice that my units cancel out for the revolutions, and I'm left over with 2 pi times 5,000, which is 10,000 pi radians. We don't need to write that word down, per minute. The next question says, find the linear speed in feet per minute of one of the 24 cutting teeth as they contact the wood being cut. So we're trying to figure out the linear speed. To find out the linear speed, there's a couple of ways. One way is that linear speed is equal to the radius times my angular speed. So we could go ahead and use that formula. Or the other way of doing it is to figure out how much do I do each minute. So per linear speed. So remember that the circumference of a circle is 2 pi r. So the distance that one of these teeth is moving is 2 pi times, and my r is 7.25 inches divided by 2. So this is the distance that one of my teeth covers each revolution. Notice that these 2's will cancel out, so I end up with 7.25 pi inches each revolution. And then how many revolutions did I have? Well, I had 5,000 revolutions. So then my linear speed is 7.25 pi inches per revolution times 5,000 revolutions per minute. Notice that the problem says that they want the answer in feet per minute, so I'm going to need to switch from inches to feet. So that means I'm going to need to use a conversion. There's 12 inches in a foot. I don't want inches as one of my units anymore, so I'm going to put inches on the bottom, 12 inches, and then I'm going to put feet on the top, and then my units of inches cancel out. So what am I left over with? I'm going to have units of feet per minute, which is exactly what I was looking for. So then you just need to multiply 7.25 pi times 5,000 and divide it by 12. When you do that, you end up with 9,490.23 feet per minute. Now the other way to do this problem would be to have used the formula V is equal to RW. So I could do the problem again. V is equal to RW. I've already figured out what W is from before in radians per minute, so all I need to do is put in what I have for my radius, 7.25 divided by 2 inches, times my omega, which is 10,000 per minute. And then we still need to do the conversion back from inches to feet, so we still need to multiply this by 12 inches per foot. And when you multiply this out, notice that these guys will cancel here. This becomes 5,000. And look at what we have here compared to what we have up here. It's the same calculation. And you end up with 9,490.23 feet per minute as your answer. The next problem says that they want us to find the linear speed in miles per hour of one of the cutting teeth. So I'm going to take the answer that I have from up here and I'm going to switch it to miles per hour. So rewriting this, I have 9,490.23 feet per minute, and I want to change it to miles per hour. So the first thing I'm going to do is I'm going to switch it to miles. To switch it to miles, I need to change it from feet. So I'm going to need to say there's going to be 5,280 feet. I'm going to put that on the bottom so they cancel out per 1 mile. So that switches it from feet per minute to miles per minute. And then I'm going to switch it to hours. So I want to get rid of my minutes. I'm going to put them up top here. There's 60 minutes in 1 hour. So I need to multiply 9,490 times 60 and then divide it by 5,280. And you end up with approximately 107.84 miles per hour.